see how we go. So the task at hand was to find a way essentially to make an expectation that we can send messages. And we've so far copied some code from the Twilio docs, this little snippet of code to authenticate ourselves and then fire off a message. So far so good, but we have to figure out how we test these things. And it's important. So I'm going to share my screen and we'll walk through it together. Okay, so I want to start off. Where do I want to start off? Let's start off on Miro. Put you at the top of the screen there. And let's just have a quick visualization of what's actually happening when we use this a bit of code from Twilio. So the way the picture that I have in my head is along the lines of our program that sort of runs over here, and we have a bit of our code. Let's say that this is like our program. This is what we're running in, or is it like message.js? Which, given that we've installed the Twilio package locally, this also exists over here. All right, that's the other bit of code that we use when we require Twilio from wherever we're at, probably in message.js. It gets some code from here, runs it, and then we can use it in our message.js. But when it actually runs, like that message.create part, let's have a look at that. Or something like, you probably had something like this. When it runs its function, the create function, something happens. And the thing that happens is it makes a request. And so there's this other bit of code here that is on a different server. It's the Twilio server that figures out what it needs to do and then sends back a result. All right, and in this case, it will probably log, as it does, some kind of set of characters, and this will be some kind of ID of the send message. The other thing that it does is send a message to your phone. That's not how phones are anymore, but it's fine. You know what I mean. Old school, all right? With a little antenna. Sends a message to your phone, and you see it pop up in black and white, clearly. So this is the kind of things, the kind of data that's happening, flowing through when you run so far that message.js and you see something pop up on your phone. You send a request, your file runs, it grabs the bit of code that you've already downloaded as a package, it runs that code, which then fires off a message create event. Twilio then handles that, sends it to your phone, then also logs back to your application the ID. Now, we have to figure out a way to test this so none of this actually happens. Right? I don't want to have to send this request to the Twilio server, then to send that would then send a message to my phone. So I essentially want to find a way to not have this part here happen. So that's the kind of visualization at the moment of what we need to do. So rather than actually just send the message, we're going to, whatever is responsible for sending it, we have to find it, isolate it. Let's put it here. Find, isolate, and then replace. Or essentially we call mocking. Oh, there you are, reminder. Okay, so that's essentially the task at hand when we try and incorporate a third-party code. In this case, it's doing other things that we don't want it to do. But in general, the idea is to find, isolate, and replace anything that we can't control. So let's have a look at this. So at the moment, it's very hard to replace things that are going on here. And so let's have a look. Now, notice I haven't stored anything in environment variables, so let's get that part out of the way very quickly. So as you see there on line 1, 2, 8, and 9, there are bits of data here that I'd rather other people not see. So at the moment I'm working locally, so this is all great, right? No one else can see this apart from all you looking at my screen, screenshotting away and saving it for your own personal use. So this is already not very good, but I trust all of you within reason. You now have access to my phone number. Look at that. The idea behind this is you don't want to store this in version control. You don't want to ask it to track this in a commit. So what we have to do is not keep the data in this file. We have to refer to it via a variable. It's a particular kind of variable called an environment variable. Now, what that means is on your machine, you have a set of variables. And everyone can have a look at this yourselves and just type into your command line env. Env will give you a bunch of environment variables. You can see here, if you scan your eyes through it, it's just a bunch of key value pairs, some of which have no values. Start at the top, you have a bunch of key and values. So it's just on the left-hand side is the key and the right side is the value. It tells me what shell I'm using, temporary directories, the username, where I'm currently working from, the home directory. There's a bunch of things that your programs or applications can use. I'm a big fan of Ruby, so I've got a lot of Ruby set up on my machine. Also notice at the bottom here, I've got some environment variables that are relevant to Twilio. And so we can add to this set of environment variables. And I can also read from it in a Node application, because any programming language can use the operating system. So let's have a look at how this works. I can just launch myself into a Node environment and have a look at all the environment variables. It's exactly the same. It's just wrapped up in a JavaScript object in the key value pairs. So you can store anything in your environment and ask to read from it in your Node application using process.env. In which case I can do something like process.env and then grab, let's say, for example, my Twilio account ID, and it gets returned to me. So the way to add to your environment variables is to use temporarily to use an export command. Let's make this bigger so you all can see. You can use export and any value, and it's all lower, and you can do it any way that you want. But say, for example, I wanted a key from test and my name, and then I can have a look at it, and you can see that I've added that key value pair to the list of environment variables. And so if I launch myself into a Node environment, I now have access to process.env.test. So as a result, I can now change all of these strings that hold sensitive data with the environment variable name. So in this case, it's something like process.env Twilio account SID, process.env auth token. The from number is the Twilio on that part. And so on and so forth.
Is it the same command in Windows?
It should be, yeah, export. If not, I'd have to look it up. As long as you're using git bash, it should just be a standard export command. Now, when you use export just like this, as I've done in the terminal, export, if you close this shell, that key value pair no longer exists. So as long as your shell is open, it will hold your temporarily set key value pairs. You can use them in your application. But if you open up another shell, you like something like this, open up a new one. And let's have a look at the environment variables. No longer any of my key value pairs exist. So just be careful. If you want them to persist, then you actually have to add them to one of the config files that start up. So if you're using so the bash shell or Z shell or other shells, you should find the config file and add it in there. So it'll be something like if you're using ZSHRC, it will be this file. If you're using simple bash, it'll just be one of these config files. And so all you'd have to do is add the export statement at the bottom of the file, something like this: export, and then the key name, and then the value. So export Twilio account SID with the value that you want, and it gets loaded every time you start up a new shell, and that'll be there. So let's recap that. For the first way, just add the export statement directly here, but know that it'll only persist for the duration of the shell that's open. If you want it for all your shells, make sure you add it as a statement in one of your config files. If you're interested about knowing which config file, just have a chat with me afterwards and we can explore it together. Sound good? Just give me a quick thumbs up if so far you're on board. Cool. Any questions? We've just gone through trying to find ways to use environment variables to store data rather than keep them here. Because now I can commit this to version control because there's no sensitive data. If someone else were to pull this code down, they would have to make sure they add to their own environment variables under these keys for this program to work, which is the point. Okay, so we've got that out of the way. Let's go back to our task at hand, which is to find a way to test this. So the first thing to do was to wrap it in a class. So let's do that part. And we wanted to call it a message. And we have to make sure we module.exports export the module. And if we have a quick look at our spec here, we want to be able to have a send method that takes in a total. So I want to have a send with a total, and it's going to do something. It's probably going to do something like this. Let's grab that and put that here. But I want it to have something that says, I don't know, your total is, and let's have something like, just keep it super simple. So wrapping the sending message in a method called send, but I need to find a way to add all this useful stuff. So let's add a constructor function to create my message with useful data. And let's just put all that in there for the moment. Okay, and all this is really doing is creating a client thing. So if I store that as my property in the constructor, and I can probably not worry about these variables. I can just add them directly into the arguments. So something like, not actually needed that much. Okay. So a little bit closer, trying to wrap this in a class in terms of the functionality, but I haven't isolated it yet. It's still that line 3 is still quite hard coded in. I want to find a way, as we said, to find, isolate, and replace. Now I'm finding it, which is the thing that's actually sending it is this client property, which stores this whatever is the result of this require. And that's the thing that can create messages. So I need to isolate it somehow, and then in my test, I'll replace it. So the way that I'm going to isolate it is to, as we've done before, find a way to decouple it. So I want to be able to pass in my own client, like not the Twilio thing, because I don't want to use Twilio in a test. But this needs to stay the same because this is important. This is the thing that's doing the useful work for me. So the way I'm going to do this is put in an optional argument. This means that I can pass in my own client and it will use that, or if I don't pass in anything, it will use the Twilio client. And the word client I'm just using is a thing that will do work for me. In this case, it will send a message. Client's kind of a generic name for something that just does some work for you. In the case of client-server relationships, clients send HTTP requests. In this case, it's just sending still sending an HTTP request, but sending a message to a Twilio server with the body, the from number, and the to number, and then Twilio takes care of the rest. But as you can see, in that simple change, let me undo that so you can see, I've now been able to isolate and replace it, and I will be able to replace it with my own version. At the moment, it's hard-coded, and here I can now replace it. I have the option to pass in my own client. So the last thing to do at the moment is I'm going to not worry about this part here on line 13 for the moment. I don't need to worry about logging to my console, the message.id. I just want to make sure I'm sending the message. And there is a way to test that, but the part 30 part of that thing happens, but I'm not going to worry about that for the moment. The most important thing to test for this class is the send method, that it's sending this create method with the right data. That's what I need to happen. So I need to find a way to test that. I need to find a way to test that this create method is being called with this data. So I'm going to grab that data and I'm going to go to my test. So this is so far what I'm doing. I'm going to use my message.send with the total. I want it to send a message. Now, I need to create a mock for the client and create a message instance. So I need to find a way to, let me put this side by side so you can actually see it rather than switch always. I need to find a way to create a client that can do these things. And that's the thing that's the tricky part here, is finding a way to do that. But let's start off with the expectation and see how far we can get with that. So it's going to be something like expect, and then I want essentially the create method. We'll figure out exactly how we get this create method. But I'm looking at this one here. I want this to have been called with this data. So there's a Jasmine match is something that is like to have been called with. And this is where I'm going to put my copy from here. And specifically in this case, it's going to be 1, 2, 3, 4, 5, 6, 7. That's some very slow addition there for you all. I guess we don't need those strings. We can just use normal strings. And that's what I want to have happened. I need to figure out exactly where the create comes from, but this is going to help create me a test that says I want to make sure that this create method gets called with this data. Expect the create has been called with the right data, so I'm just going to get rid of that for a moment. So where does create come from? Well, create is going to come from the client messages create. So I can do something like, I'll call it client mock messages create. So where does this come from? So this is what I have to do now. Create a mock for the client, create a message instance. So the message instance will be something like let's use a const. Const message is a new message, and we're going to pass in. We have to pass in our own client because I don't want it to default to the Twilio. So we're going to use an object I'll create in a second. And so what does that look like? So this is that part done. And the mock is going to replicate this behavior. So let's have a look at what this is. Const client mock. It's going to be an object that has a messages property. And this messages property has a create function. So it's going to be an object that has a create function. So I've just replicated the ability for this client mock to have a messages property, which then has a create function. So I use this fake version or this mock of a client. I send it in with my new message. And I need to find a way to spy on it to make sure that I can set up this matcher. So let's spy on something like this, and specifically the create method. This allows me to assert now on whether methods have been called. So there are two parts to an assertion like this. One is making sure I set up my test and then assert that a method call happened. So this is all trying to replicate the functionality that I'm using here on the left, making sure that I don't actually send a message, but making sure my coding the important things, which is asking for the property on this.client and then calling the create function with the right data. Okay, so we'll run this test in a second and see where we get to. Can I, before I do that, can I get any thoughts or questions about the approach that I've taken so far?
Yeah.
I think I'm confused why the client mock is empty. So how does the test actually know that the create function is supposed to like be all the body and from and to?
Yeah, I think that's a good question. Say that again.
So why is the client mock just messages and create without actually having any code inside of the function? So how does the test know what's supposed to be in it?
Yeah. So I don't really care what the create method does. Okay. Because here I'm just calling it. The create method is part of the Twilio library. Right. If you want to have a look at what the create method does, go explore the Twilio package. But that's not the point here. The point here is making sure that whatever it is, it gets called. Okay, and gets called with an argument, specifically in the format of an object that has 3 keys, body from to with these strings. So I don't care what it does. It just needs to exist so I can call it. In which case, I've just created a blank function to make sure it gets called. and then I make sure it gets called with the right data. Because Twilio is tested by itself. Twilio has a fully tested create function. I don't need to worry about what it does. I just need to make sure my code calls it. Yeah. This is the cruxes. That's a really great question and an important one. I don't care what it does. I just have to make sure I call it. Twilio has tested it itself. Like I rely on the fact that Twilio has tested what the create function does.
Is it possible to do without class double?
Say again.
Is it possible without making a client mock? Can you do it without doing that, like a test double?
I'm not sure I understand the question. Is it possible to do what I'm doing without doing what I'm doing? Is that what you're saying?
No. Is it possible to do, like, I guess, spy on like Twilio's require rather than make a constant client mock?
It's difficult because you'd have to add that code in to wherever the Twilio object gets created. So you have to find a way to expose it to then spy on it. Okay. And if you hard code it, it's almost impossible to do that in an elegant fashion, and it becomes very painful. And so the technique we're learning here is always to find where those things are, isolate them, and then replace them in tests, so you can control the behavior. More questions or thoughts? Cool. Let me minimize your faces again. Okay, so let's run these tests and see how far we get to. So I want to run my shop spec at the moment. Let me just make sure I can fail my test. Cool. So it's always fun when things pass the first time round, but usually you write a failing test and then you update it. In this case, you've done it inverse. I've written the source code, making sure it's working, and then the spec has been written. So as you can see here, my assertion now is checking that this create method is called, but with the right data. So if I change this, let's say I add in more information here. So assume my test is correct. Cool, tests are passing, and someone comes in and changes my source code, saying actually the body is now going to say your total is with an exclamation mark. Yay! Now that should mean your test should fail. They've changed your source code without updating your test. Let's run the test, and you can see here there's now a broken expectation. It wants to make sure that you call it with the right data, and you've changed the data. And I'm not relying at all on actually sending a message, because I've replaced the Twilio code. However, I can still get my code to run without changing my source code. Let's change that back by going to index.js and running it here. So it should still work all perfectly, but I'm now no longer using a mock for my message. It just uses its default Twilio behavior. So if I run that, and then you can't really see, you have to trust me, but I've got it on my phone. So this exercise has been designed so you can have a look at how you can use third-party code and make sure you test your implementation of it, but not actually have to test what it does. And that's an important distinction to make. And the way that we've done that is by isolating and finding where the dependency is. In this case, it's the require part here. isolating it and then replacing it in our tests with the version that replicates its behavior. The way that we've done that is we created a simple object that replicates the sort of property and functions here on the left, .messages, .create, like this. So we have a messages and create, and we're just making sure that we can spy on that method and assert that it's being called with the right data.
If you uncommented line 13 in your source, does it break your tests?
Yes.
Why?
Because the create method needs to return something that responds to the then method. So you'd have to add more information here exactly on the spy to create and return a value that responds to them, and that's a promise. It'll be something like doesn't really matter what it is. It could just be an empty string, whatever it is, or just get logged. But as you notice on line 13 in the source code, it doesn't actually do anything apart from log to your console. So it's actually irrelevant unless you needed the ID. But we're not worrying about that. Okay, so what I want you to do now is go back and have a look at this and look at the solution directory and have a look at how it's working. Hopefully it's somewhat similar because I did it this morning to what I just did. And have a go getting it to work yourselves. Have a look at the flow here. And the important thing here is understanding how this mock was set up to replicate the behavior, making sure we spy on the method and then assert that it was called. Yeah. Okay. And give me a quick thumbs up if that makes sense of what we're going to do for the next 20 minutes. I want to wrap up by 11:30. Cool. So everything that you use in the solution directory, go back into your pairs and try to implement it yourselves, and then we'll wrap up at 11:23. Yeah. Okay. Stopping sharing, and away you go. Hi folks, welcome back. Let's jump onto the mirror board, and I just want to know what questions that you have at the moment. As you went through that, how did you find it? What are your thoughts and any questions at the moment? So jump on the mirror board, and on that space where I did the little diagram, just whack on a post-it note of like any questions that you have. When thinking about the objective of, or the two objectives that we have this morning, which is use some code from a third-party library and explain a testing strategy. How do we test that code? What questions do you have, and what are your thoughts when you think about the key things you learned this morning? Well, I see there's a couple of thoughts down here at the moment. It sounds like it's fine. I would like to learn more about spies. What does the spy on do exactly? Cool. I think the intention of learning more about spies is great. So use the Jasmine docs, have a look at them and play around with them, and have a look at the example. What does this? All sort of testing frameworks have some version of this, a mocking library or a snubbing library to have a look at. And the way that Jasmine implements it is fairly standard, which is good. What does the spy on do exactly? The best place to have a look at this is the Jasmine documentation. You can have a look at that and start there, and then dive into the GitHub code for that method. At a high level, if we have a look at the Jasmine docs, it says spy can stub any function and tracks calls to it and all arguments. So once you've set up the spy to stub a function, anytime you call it, we can track how many times it calls and any arguments for that call. So it's a great way to be able to assert your code is behaving as you want it to, and making sure methods are being called with the right arguments. Essentially, think of it as like someone putting like a little bug on your code as you're walking down the street. They can then hear everything that you say. In the same way that you've got to make sure it gets bugged first before you make the assertion run. So you've got to set up your spy, and then you can assert. Cool. Any other thoughts or questions? Okay, so thinking about these two objectives that we have, just give me a thumbs up and we'll do it one by one. So the first objective that we have is use code from a third-party library to project. And the thumbs up means, yeah, be able to use it, have some difficulty with it, and this is having yet managed to implement it. Give me a quick thumbs up. or however flimsy you want. Cool. And then the second one is, can you explain how to test third-party code? This is, I have a good explanation. This is, I kind of can explain it, and this is, I don't. Cool. Okay, so it sounds like we've got to do a little bit more work on that last part, which is good to know. The follow-up from this exercise is to spend some time looking through the code that I've given. You can rewatch the recording and try and write down an explanation for yourself of how the test was set up. Start there, and then you can always send it to me for a sanity check, and we can go through it together. And that should be a good first step to follow on from this exercise to explain how to test in this example. How does that sound? Yeah. Send it to me directly or share it in the cohort channel. This is our first exposure of using third-party code and developing a strategy to test it. Let's wrap there. So thanks, folks. The rest of this morning is your own time to continue work with the Gilded Rose, and we'll see you all at stand up in the afternoon at 2 to 2:30. See you then. Goodbye.